On a warm September morning in 1977, a rocket lifted off from Cape Canaveral carrying one of the most ambitious scientific missions ever attempted. Inside its payload fairing was a spacecraft no larger than a small car, built to visit the giant planets of our solar system. Engineers expected the mission to last only a few years. Instead, it became one of the greatest adventures in human history. That spacecraft was Voyager 1. Its first destination was Jupiter, a world so enormous that more than 1,000 Earths could fit inside it. When Voyager arrived in 1979, it transformed a distant point of light into a living planetary system. The spacecraft photographed massive storms larger than Earth, powerful lightning flashes, and colorful cloud bands stretching thousands of kilometers across the planet. Then came one of its greatest surprises. Voyager discovered active volcanoes erupting on Jupiter's moon Io, making it the first world beyond Earth where active volcanism had ever been observed. Lava fountains rose high above the surface, proving that the solar system was far more dynamic than scientists had imagined. After leaving Jupiter, Voyager continued toward Saturn. Its cameras revealed breathtaking rings composed of countless particles of ice and rock, arranged in delicate structures unlike anything previously observed. The mission also examined Saturn's mysterious moon Titan, where a thick orange atmosphere concealed the surface below. By the early 1980s, Voyager had completed every major objective planned before launch. Its primary mission was over. Yet the spacecraft remained healthy. Its systems continued operating flawlessly, and enough power remained to keep several scientific instruments active. Rather than ending the mission, NASA made a remarkable decision. Voyager would continue traveling outward, leaving the familiar planets behind and venturing toward the unknown frontier beyond the solar system. For decades, the spacecraft quietly crossed billions of kilometers of empty space. Gradually, the influence of the Sun became weaker. The stream of charged particles known as the solar wind slowed as Voyager approached the outer boundary of the heliosphere, the enormous magnetic bubble created by our star. Scientists had long predicted this region, but no spacecraft had ever reached it. Finally, in 2012, Voyager crossed the Heliopause and entered interstellar space. For the first time in history, a human-made object began directly sampling the environment between the stars. The discoveries were extraordinary. Instead of completely empty space, Voyager found a vast ocean of plasma, magnetic fields, and high-energy cosmic rays flowing through the Milky Way. Its instruments detected changes in particle density and magnetic conditions that continue helping scientists understand how our solar system interacts with the rest of the galaxy. Every measurement became something entirely new. There were no previous missions to compare with. No maps. No guidebooks. Only fresh data arriving from a spacecraft traveling farther than any machine had gone before. The mission itself became an engineering miracle. Voyager's computers were designed with 1970s technology and possess less computing power than even the simplest modern electronic devices. Yet through careful planning and decades of dedication by engineers, the spacecraft continues functioning nearly half a century after launch. As its power supply slowly decreases, mission controllers carefully deactivate instruments one by one, preserving enough electricity to continue collecting the most valuable scientific observations. Each additional year is considered an extraordinary achievement. Today, Voyager 1 continues moving away from Earth at more than 17 kilometers every second. Its radio signals require nearly an entire day to reach Earth, making communication slower than with any other active spacecraft. Despite that enormous distance, Voyager remains connected to humanity, faithfully sending back information from a place no one has ever explored before. Its journey reminds us that exploration does not end when the map runs out. Sometimes, that is exactly where discovery begins. As Voyager 1 continues its silent voyage through interstellar space, it carries something far more valuable than scientific instruments. It carries a message from Earth. Attached to the spacecraft is a gold-plated record, often called the Golden Record. Created by a team of scientists, artists, and communicators, it was designed as a time capsule for the cosmos. If an intelligent civilization were ever to discover Voyager in the distant future, this record would serve as an introduction to humanity. Encoded within it are greetings spoken in dozens of languages, sounds from nature, music from different cultures, and images representing life on Earth. It is a snapshot of an entire world placed aboard a spacecraft traveling between the stars. Whether anyone will ever find it remains unknown. Yet the record represents something profoundly human, the desire to connect, even across unimaginable distances. While the Golden Record captures our hopes, Voyager's scientific instruments continue revealing the reality of interstellar space. For many years, scientists imagined the region beyond the solar system as relatively calm and uneventful. Voyager's observations have shown a far more complex environment. The spacecraft has detected changes in magnetic fields, variations in plasma density, and streams of energetic particles moving through the galaxy. These measurements help researchers understand how stars influence their surroundings and how cosmic radiation travels through the Milky Way. Every new dataset improves our understanding of the neighborhood beyond our solar system. Some of the most fascinating discoveries involve plasma waves. Plasma, often called the fourth state of matter, fills much of the universe. Although humans cannot hear these waves directly, scientists can convert the measurements into sound. The result is haunting. Instead of silence, interstellar space reveals a subtle chorus of vibrations and frequencies generated by charged particles moving through magnetic fields. These signals provide clues about the density and structure of the material between stars. What once seemed like an empty void is proving to be a dynamic and active environment. Voyager's journey has also inspired future generations of explorers. Many modern concepts for interstellar travel trace their roots to lessons learned from the mission. Projects aimed at reaching nearby star systems often cite Voyager as proof that long-duration exploration is possible. Although current technology cannot transport humans to another star within a reasonable timeframe, researchers continue developing innovative ideas. Some concepts involve miniature spacecraft propelled by powerful laser systems. Others explore advanced propulsion technologies that could dramatically shorten travel times. The dream of reaching another star remains distant, but Voyager transformed it from fantasy into a legitimate scientific goal. Its legacy extends beyond engineering and astronomy. Voyager changed the way humanity sees itself. One of the spacecraft's most famous images was captured in 1990 when mission controllers commanded it to look back toward home. From billions of kilometers away, Earth appeared as a tiny speck suspended within a beam of sunlight. That photograph became known as the pale blue dot. In the image, every person who ever lived exists within a fraction of a pixel. Every nation, every city, every triumph and tragedy, all contained on a world that appears almost invisible against the vastness of space. The image offered a powerful reminder of both our smallness and our significance. It showed that despite our differences, we share a single home drifting through an immense cosmic ocean. Today, Voyager 1 continues its journey deeper into the galaxy. Its power supply will eventually become too weak to operate its instruments, and one day its transmissions will cease forever. But even after its final signal fades, the spacecraft will continue traveling. For thousands, perhaps millions of years, it will drift among the stars as a silent monument to human curiosity. Future civilizations may come and go. Continents on Earth may change. Entire chapters of human history may unfold. Yet Voyager will remain out there, moving through the darkness, carrying evidence that a technological species once emerged on a small blue world and dared to explore the unknown. Its mission is more than a story about science. It is a story about persistence. About imagination. About a species unwilling to remain confined to the horizon it can see. Nearly 50 years after launch, Voyager 1 still reminds us that the greatest discoveries often begin with a simple question: what lies beyond? And somewhere in the vast darkness between the stars, humanity's oldest explorer continues searching for the answer.